On the 6th of September 1990, King Carl Gustaf XVI of Sweden and ESA Director General Reimar Lust inaugurated Kiruna Station. It consisted of a newly constructed station building, a primary and emergency power plant, roads, data cables, a calibration site, and a single 15-metre dish antenna, Kiruna 1. The station was initially conceived for the support of the polar orbiting ERS missions. ERS-1 launched in 1991, followed by a second satellite, ERS-2, which launched in 1995. In 2000, a second antenna, Kiruna-2, was constructed to support ESA's Envisat mission, then the world's largest civilian Earth observation satellite. Today, Kiruna is supporting all of the Sentinel satellites flown by ESA, as well as ESA's Earth Explorer satellites, Aeolus, Swarm, and Cryosat-2, and the scientific missions, Cluster, Cheops, and ESA's Gamma Ray Observatory, Integral.
Kiruna Station typically supports Earth observation mission. This kind of mission is normally describing polar orbits. And polar orbits, from the name itself, are orbits that are passing close to the poles every orbit. The speed of an Earth observation satellite is typically 7.5 kilometers per second, meaning like every 100 minutes it will do a full revolution around the Earth. Kiruna, therefore, is located very far north, more than 100 kilometers above the Arctic Circle, in order to provide support to this kind of missions, which will have more occasions to communicate and to have passes in the North Pole with respect to another antenna that could be located, for instance, close to the equator.
In a typical month, more than 750 hours of communication link-ups are made between Kiruna and passing satellites, up to 15 different spacecraft in all. This means the station is providing an average tracking support for over 25 hours each day with its 2 antennae. For most Earth observation satellites, these communication passes are done in a very tight time window of 8 to 12 minutes, while the satellite is in direct line-of-sight view. For a scientific satellite like Integral, a pass typically takes more than 50 hours. These passes enable the station to download vital science data and telemetry and upload fresh commands for the coming orbits.
There are 2 kinds of data that we collect. So the science data, so to speak, which often gets downloaded over Kiruna. It's saved there after the pass, and it's transferred to whichever processing center we're working with, typically ESRIN. Then we also have the housekeeping telemetry, which is the telemetry which indicates the health status of the spacecraft, amongst many other things. And this one is also transferred usually after a pass offline to our systems, where we ingest it and process it.
Kiruna is part of ESA's ESTRAC network, which is a global system of ground stations linking European spacecraft with the agency's ESOC Mission Control Center in Darmstadt, Germany. The Kiruna ground station is remotely operated from ESOC during routine operations, while the local maintenance and operations team takes care of day-to-day troubleshooting on site. This local team also provides support to spacecraft during critical phases, such as the hours immediately following launch. Kiruna's ability to establish real-time contact with newly launched satellites is vitally important for mission controllers. In 2020, Kiruna will support the launches of SEOSAT and Sentinel-6A, European missions that will deliver critical data on land use and oceans. As space technology develops further and space becomes increasingly important to daily life, Kiruna Station will need to continuously evolve to support new missions and technologies, while the amount of data gathered by satellites grows exponentially.
ESA aims at further evolving the station to keep on playing a fundamental role in the support of this mission during critical and routine phases, as well as to serve as a reference facility for the validation and troubleshooting of new technological developments. So 30 years has served to consolidate Kiruna as an ESTRAC reference station for the support of near-Earth communications. and solid foundations are laid to continue its expansion and development to the support of the mission to come.
Kiruna is a vital link between Earth and space. Today's space technology is ever present in our daily lives, and while we might often reflect on the importance of satellites orbiting our planet or spacecraft studying our cosmos, we should not forget the crucial ground stations like Kiruna, how they make space possible, and how they help humanity move into the future.